Imagine a hidden network, far vaster and more powerful than any highway system, constantly shaping our world. Beneath the shimmering surface of our oceans lies a secret realm, a dynamic labyrinth of colossal waterways. Right now, massive rivers of water moving beneath the ocean's surface are determining whether your city floods or faces drought. And most people have no idea they exist. These aren't rivers in the traditional sense, but immense, flowing currents of water stretching for thousands of miles. They are the ocean's circulatory system silently orchestrating global climate patterns. These invisible rivers are the unsung architects of our weather, dictating where rain falls, where droughts persist, and even the intensity of storms. Transporting heat from the equator towards the poles, they influence atmospheric pressure systems and steer moisture-laden air. A slight shift in their path can mean the difference between a parched landscape and devastating floods for coastal communities or even inland regions. These are ocean currents, vast streams of water that dwarf any river on land. They are the planet's true superhighways, moving not just water but heat, nutrients, and marine life across vast distances. Consider the mighty Gulf Stream, a titan among these currents. A titan among these currents. It's a liquid conveyor belt carrying an astonishing volume of water. The Gulf Stream alone carries more water than all the world's rivers combined, over 1,000 times the flow of the Amazon River. This colossal river of warm tropical water originates in the Gulf of Mexico and Caribbean, then surges northward along the eastern coast of North America, eventually crossing the Atlantic. It moves warm tropical water northward at speeds that would make a leisurely bicycle ride seem fast, reaching up to 2.5 meters per second. This warm current is directly responsible for the surprisingly mild climates of Western Europe, preventing it from being as cold as Canada at similar latitudes. Without it, cities like London and Paris would experience far harsher winters, more akin to those in Siberia. But this isn't just about moving water. It's about a colossal, intricate dance of heat, salt, and energy that fundamentally controls our planet's climate and weather patterns. This vast oceanic circulation system, often called the global conveyor belt, is more scientifically known as the thermohaline circulation, named for its dependence on temperature, thermo, and salinity, haline. It's a continuous, slow-moving loop of ocean currents that connects every single ocean basin on Earth, acting as the planet's primary heat distribution system. Imagine a planetary circulatory system moving immense volumes of water over vast distances. Here's how this incredible natural engine works. The journey begins in the sun-drenched tropical regions, where warm, salty water, heated by intense solar radiation, flows northward across the ocean surface. As this surface current, propelled by winds in the Earth's rotation, travels towards the higher latitudes, particularly the North Atlantic near Greenland and Norway, it undergoes a dramatic transformation. The water gradually loses its heat to the colder polar atmosphere, causing its temperature to plummet. Simultaneously, as ice forms in these frigid regions, the remaining seawater becomes even saltier, as salt is expelled from the freezing ice. This combination of extreme cold and increased salinity makes the water incredibly dense, far denser than surrounding warmer, less salty water. When this super dense water reaches critical points, it can no longer remain at the surface. It begins to sink, not gently but in powerful, cascading plunges that create what scientists describe as massive underwater waterfalls. Imagine currents equivalent to hundreds of Amazon rivers flowing vertically downwards, sometimes to depths of several kilometers, all the way to the ocean floor. This deep convection, occurring in key areas like the Labrador and Greenland seas, is a critical engine driving deep ocean currents. Once at the bottom, this now cold, dense water forms a deep ocean current. It then embarks on an incredibly slow, centuries-long journey, flowing southward along the abyssal plains, tracing the contours of ocean basins. This deep current eventually reaches the Southern Ocean, branching out into the Indian and Pacific Oceans. In these distant parts of the world, often thousands of miles away, this deep water gradually warms and mixes with other water masses. Through a process called upwelling, driven by seafloor topography, winds, and subtle density changes, it slowly rises back to the surface, completing its epic global circuit. This continuous cycle is vital, distributing warmth from the equator to the poles, regulating global temperatures, influencing marine ecosystems, and shaping the air we breathe. Without it, our planet's climate would be drastically different and far less stable. This vast, intricate circulation system is, in essence, our planet's most sophisticated climate control mechanism. It's a dynamic, global network of ocean currents and atmospheric flows constantly working to redistribute heat and moisture across the Earth's surface. Think of it as the planet's circulatory system, pumping life-sustaining warmth and vital precipitation to every corner. This incredible system meticulously regulates temperature across continents, dictating where lush rainforests thrive and where arid deserts form. It determines the very rhythm of our seasons and the patterns of rainfall that sustain agriculture and ecosystems worldwide. It's a delicate balance, finely tuned over millennia. But when this colossal system shifts even slightly, the repercussions are felt globally. We witness phenomena like El Niño and La Niña, the powerful warming and cooling phases of the Pacific Ocean's ENSO cycle. These aren't just minor fluctuations. They are massive disruptions that ripple across the globe, triggering extreme weather events with devastating consequences. An El Niño event, for instance, can dramatically alter global weather patterns, leading to prolonged droughts in Australia, fueling catastrophic bushfires and crippling agricultural output. Conversely, it can unleash torrential floods in California, causing widespread destruction, mudslides, and immense strain on infrastructure. In India, these shifts can mean failed monsoons, jeopardizing food security for millions and impacting the very livelihoods of farming communities. The delicate balance of global weather is thrown into disarray, impacting everything from crop yields to disaster relief efforts. Consider the warm Gulf Stream, a powerful ocean current originating in the Gulf of Mexico. This oceanic conveyor belt carries vast amounts of tropical heat across the Atlantic. It's the primary reason why London, despite being at the same latitude as the notoriously frigid Labrador in Canada, enjoys relatively mild winters. London benefits from a temperate climate, allowing for lush greenery and a vibrant outdoor culture, while Labrador remains locked in ice for much of the year. Without the Gulf Stream's constant flow of warmth, much of Europe would be plunged into an unrecognizable, ice-locked landscape. Cities would be buried under snow, agriculture would become impossible, and the very fabric of life as we know it across the continent would be fundamentally altered, transforming it into a frozen wasteland. It's a stark reminder of how profoundly dependent our habitable world is on these magnificent, yet fragile, natural systems. But here's what should truly keep us awake at night. This vital system, the Atlantic Meridional Overturning Circulation, or amoc, is showing alarming signs of distress. It's slowing down. For centuries, the amoc has acted like a colossal global thermostat, distributing heat from the tropics towards the poles, especially warming Western Europe. The primary culprit? Our rapidly melting Arctic ice. As colossal glaciers and ice sheets disintegrate, they unleash vast quantities of fresh water directly into the North Atlantic. This influx of fresh water is less dense than the salty ocean water. Normally, the cold, dense, salty water in the North Atlantic sinks, driving the deep ocean currents. But with this freshwater dilution, the water becomes less salty, less dense, and crucially, less likely to sink. Less likely to sink. It's like trying to make a heavy object float. The fundamental physics are being disrupted. Scientists aren't just speculating, they've detected a measurable decline. Over the past century, the Atlantic circulation has already experienced a significant 15% slowdown. This isn't a theoretical future problem. It's happening now. And the rate of slowdown appears to be accelerating. Leading climate models and recent studies suggest we might be approaching a critical tipping point, a threshold beyond which slowdown could become irreversible, or even lead to a complete shutdown. If this planetary conveyor belt were to grind to a halt entirely, the consequences would be nothing short of catastrophic, reshaping our world in unimaginable ways. For Europe, the impact would be immediate and brutal. The warm currents that moderate its climate would vanish, plunging the continent into a mini ice age. Imagine winters far colder than anything seen in centuries. Energy demands would skyrocket, straining infrastructure, ending infrastructure, ending infrastructure, and economy structure, ending infrastructure, ending infrastructure, ending infrastructure, and economy structure, ending infrastructure, and economies. This isn't just a slight increase. It means entire coastal cities, from New York to Miami, would face unprecedented flooding, mass displacement, and the destruction of critical infrastructure, billions in economic damage, and countless lives disrupted. The monsoons that are the lifeblood for billions in Asia, crucial for agriculture and drinking water. Drinking water could fail billions in Asia, crucial for agriculture and drinking water, could fail entirely. This would trigger widespread drought, famine on an unimaginable scale, and potentially mass migrations, creating humanitarian crises that dwarf anything we've witnessed before. The delicate balance of global weather patterns would be thrown into chaos, impacting rainfall, temperatures, and extreme weather events across the globe. This isn't just a regional issue, it's a global existential threat. The latest IPCC reports paint a stark picture. We're rapidly nearing critical tipping points for our planet's most vital systems. These aren't abstract concepts. They represent thresholds beyond which irreversible changes could profoundly impact global climate and our ocean currents. But here's the crucial message. We are not powerless. Our greatest strength lies in knowledge. Understanding the intricate mechanics of these vast, invisible rivers, how they transport heat, nutrients, and influence weather, is the foundational first step. It allows us to predict, prepare, and devise effective strategies for their protection. Without this comprehension, our efforts would be blind. The science is clear. Unchecked greenhouse gas emissions are disrupting these ancient currents. Yet every action, no matter how small, contributes to a larger solution. From renewable energy and efficiency to advocating for robust climate policies and conscious consumer choices. Each step we take to reduce our carbon footprint directly alleviates pressure on these vital ocean currents. These are the very currents that have acted as Earth's global thermostat, regulating our climate for millennia, enabling life as we know it. These invisible rivers beneath our oceans aren't just natural phenomena. They are silent architects of human civilization for millennia. Their stable patterns dictated weather, influenced agriculture, facilitated trade, and guided human migration, providing the consistent climate backdrop for societies to thrive. But now, the roles are reversed. The future of these magnificent, life-sustaining currents rests squarely in our hands. It's our collective responsibility to shape their future, ensuring they regulate our planet for generations. This isn't just about preserving nature. It's about safeguarding our very existence. This isn't just about preserving nature. It's about safeguarding our very existence. Subscribe to KnowverseTV for more science-based knowledge that matters.